Okay, hello everyone. Welcome back from the morning break. I hope you have a nice breakfast just now. The next speaker is Mate Fejis, is in charge of the Innovatrix Asia Pacific Regional Office based in Singapore. Apart from taking care of the key accounts and large-scale government projects, he actively seek for a new ways of leveraging biometric technology that brings value and innovation into our everyday life. As a biometric system specialist, he has over 10 years of experience leading the analysis, proposal, implementation, and delivery of the digital identity solution. So please welcome Mate Fejis, Regional Sales Director for Asia Pacific Innovatrix Singapore. You can take the floor.
Hello, Fred, and thank you very much for having me here, and good morning, everybody. My name is Mate Fejis. I represent Innovatrix for the APAC region, and at Innovatrix, we build large-scale biometric solutions for governments and enterprises using our own proprietary biometric technology for face, fingerprint, and iris recognition as well. Today, we are going to talk about how to leverage on face recognition technologies and the solutions built up on top of those to make our workplaces smarter, more efficient, and of course, more secure. Face recognition technologies as such, of course, have been around for the last couple of years at our workplaces. And the adoption of those technologies have been an ongoing process for the last couple of years. But the recent pandemic, of course, accelerated that adoption. And at the same time, it created a lot of new challenges, a lot of new problems that we as technology providers, we have to solve. And those solutions, of course, are expected immediately. And that's exactly the reason why face recognition technologies have never been evolving at such an extreme pace as now in the last 1 or 2 years. So let's first take a look at those key pain points that are really keeping us busy in the last 1 or 2 years. So first of all, non-touchless manual processes are bothering us. Using access cards, for example, besides the hygiene issues, it's also not too secured, right? So it's easy to misuse, it's very easy to lose cards, very easy to steal cards. On top of that, they create manual processes which take some time. People are looking for their cards, digging in their pockets, blocking others, creating queues. So it's not so efficient and not so secure. Different credentials are being used for different use cases: fingerprints for time and attendance, access cards for access control, and of course the good old passwords for every single corporate tool that we are using, all the virtual or logical platforms like our mailboxes, our CRM, our HR tools. For every single one, we have to memorize and type a different password, or we can use the same password for everything, which is not exactly recommended. But at the end of the day, we need a separate identity management mechanism for all those physical or logical access points, including time and attendance, access control, and our CRM or our mailbox. There's also another group of workplaces which are facing a completely different set of problems, and those are workplaces with huge number of employees, huge number of workers, which they have to receive every morning within a rush hour. The clearance of workers must be done within, let's say, 30 minutes, and we are talking about thousands of workers. The same number of workers are leaving that workplace in the afternoon, and these workplaces need a clearing system with very high throughput. Many of the existing solutions cannot really achieve this high throughput, even if some sort of face recognition solution is in place, because all those people still have to stop at these turnstiles, look into the camera of some sort of face recognition device, wait a couple of seconds while they're blocking others. So they cannot really achieve a high throughput, they cannot really achieve a seamless experience of the clearance of that high number of people. And again, manual processes over and over again. So let's take a look at this gentleman waiting for the elevator, and let's imagine this is our colleague coming to work. let's call him John. And we know John, we know that he arrives every single morning to the same office building. He drives his car to the same car park, enters the same building, crosses the same door, uses the same elevator, goes to the same floor and punches in at the same office. But still, we let John do all these things manually over and over again. Look for his key, look for his access card, use his fingerprint to punch in, select floor 7 to make the elevator take him to floor 7, and so on. So all those processes are still manual. So to sum it up, the key pain points that we have to focus on when it comes to face recognition at our workplaces are too many manual processes, which are it would be possible to automatize those processes, and a lot of interaction is needed. We have to actively interact with the turnstile, with the time and attendance terminal, and with the elevator. And with all these endpoints, including our personal devices, cell phones, PCs, we have to use different credentials to access them. We have to use different ways of proving our identity. Of course, traditional problems like identity spoofing, body punching, tailgating are still around. We still have to take care of them. And of course, in the last 1 year, non-touchless solutions are becoming practically unacceptable. So what are the painkillers and how we can solve these problems using technology? Let's start with the idea of our destination, where we want to get. So what we want to get is some sort of seamless walkthrough or drive-through experience where we don't have to stop and prove our identity at every single touch point. It would be really nice just to walk into the office or drive our car into a car park without doing a thing, and all the doors open automatically, our arrival is recorded, and we are punched in automatically in a completely seamless way. Of course, it must be completely touchless. Ideally, we want to use only one single source of identity and one single way of proving our identity. And since, of course, we are going to solve these problems using face recognition, we also have to mention 2 more requirements here, which are very common and being emphasized in every single conversation when it comes to face recognition. And those are face mask detection and at the same time accurate identification of faces while there is a mask on, and liveness detection. Face recognition is the most convenient biometric modality when we compare it to fingerprint or iris recognition, for example. And nowadays, face recognition is also accurate and powerful enough to handle a larger database like tens or hundreds of thousands of users. But at the same time, face recognition is also very easy to spoof. It's easy to show a photo of a different person. So we as technology vendors, of course, we still have to take care of these problems as well. In this presentation, we are going to show you a few case studies from the field. So I'm going to use videos to show you how we implement all these painkillers and how we improve our experience and security at workplaces. Before we get there, let me show you a very simple concept of the whole solution from a bird's eye view. What we did, we built a platform called Smartface. Smartface is a real-time face recognition and identity management platform, which is able to handle multiple different endpoints, touch points, and tools which are already there, are already with us at our workplaces. And those are the elevator, the physical access points, the turnstile, some sort of registration point for visitors, for example. It can be a reception with a receptionist, or it can be a kiosk. We have different security and face recognition cameras. We have personal devices. All these endpoints are opportunities to prove our identity. Actually, these endpoints are forcing us to prove our identity in some way. When I place my card on the turnstile, or I type my PIN code on my cell phone, but even when I enter the elevator and press number 7, which is my floor I want to get to, those are ways to claim an identity which must be proven some way. So why not to unify all these things and to use a central source of identity with a unified identity token, which is the most convenient identity token, our face. In the next few videos, I'm going to show you a few case studies from real deployments. And so I'm going to show you how these solutions perform in action. In the first video, we are going to use this scenario. This is, by the way, our HQ office. This is the Innovatrix HQ office lobby in Slovakia, in Europe, where, as you can see, we have a couple of elevators, we have a couple of turnstiles here. And what we use is this face recognition camera, which is basically any kind of off-the-shelf camera, a webcam or an IP camera. The solution is hardware agnostic, so we can just plug in any kind of camera and just put it on the turnstile. This is a real-time face recognition camera, which is going to recognize multiple people, multiple faces simultaneously, and evaluate multiple factors so we can trigger some action, opening the door, closing the door, triggering the elevator, and so on. We also use a feedback screen, which again can be any kind of Android tablet. It can be a standalone screen, any kind of tablet or screen. Again, we just plug it into the central platform, which is hardware agnostic. So we just use the screen to give some feedback for the user, just so we make the whole solution a bit more user-friendly. But practically, technically, it's not necessary. In this first video, I'm going to show you how one of my colleagues is going to enter this lift lobby here. This colleague of mine is a registered user. He's allowed to enter. He's wearing face mask. Basically, he is playing by the rules. He meets all the requirements. What we want to achieve in a modern workplace is not to bother these kind of users by stopping them and forcing them to prove their identity. We want to make their life easier. We want to make them just keep walking seamlessly through this turnstile, enter the elevator, and do everything they need to do, right? Without forcing them to look for keys or place their finger on a reader or stop at the turnstile. So in the next video, it's going to be very fast. This person is going to walk through this turnstile completely seamlessly, while his face will be recognized and evaluated simultaneously in a real time. So let's see this first video now. What you could see in the first video was a complete seamless walkthrough experience. This turnstile was triggered by the face recognition. So while this person was walking towards the turnstile, during this, his face was being evaluated, the person was identified. We knew that this person is allowed to enter. We also detected that the face mask was present, and we kept monitoring and observing his movement, his intention. And when he got close enough to the turnstile, we triggered the door automatically, just displayed a welcome message on the feedback screen, and he just kept walking. He didn't have to interact with any kind of endpoint. He didn't have to prove his identity. He didn't even have to slow down or look into the camera. He just kept walking seamlessly. So obviously, this is the user experience and the efficiency part of the whole story. But we're talking about workplaces and security. So let's now take a look at the security portion of the whole story as well. In the next part of the video, this person is going to take his mask off and turn towards the turnstile. So let's see what happens then. The immediate response of the system on the feedback screen is, put your mask on, please. And of course, the door doesn't open. Don't forget that this is a real-time face recognition solution. So this is not the final result of this whole journey. This is not the end. It's still not over. We still keep evaluating this person in a real time. We keep evaluating his position, his distance from the turnstile, his identity, of course, and many other factors, including the presence of the face mask. So in the next few seconds of the video, when the mask is back on, the door is triggered immediately, the welcome message is displayed, and he can walk through again. In the last part of this video, another person is going to try to enter this building. And this now is going to be an unregistered or unknown or for some reason unauthorized person. So when this person approaches the turnstile, of course, the immediate response is not opening the door and showing the corresponding message on the feedback screen. Passage is not allowed. He tries to change his position, hide and show up again. He does multiple tries, but still the result of the system is exactly the same. So this is how we can achieve a completely seamless experience while we keep the highest possible level of security and we keep checking all the factors which are required. This was very smooth, this was very fast and easy, but of course, on the background, within this technology, there are a lot of things, there are a lot of tricks we have to do to achieve this kind of user experience and security at the same time. I would like to highlight a few of those tricks. One of those tricks is what we call watchlist auto-learn. It's very typical, especially in access control systems and time and attendance systems, that exactly the same group of users, even if that group is a large group of hundreds of thousands of users or millions of users, but the same group of users keep showing up in the same office every single day, crosses the same turnstile every single day, enters the same office every single day, punches in the same time and attendance system every single day. We can leverage on the fact that we keep seeing, our face recognition system keeps seeing exactly the same people every single day for months or for years. So what we can do, we can learn how those people change their appearance. There is a question, a very frequently asked question, which our customers keep asking me all the time. They ask me, hey, Mate, how frequently we have to update the reference photo in your face recognition system? The answer is always, you don't have to. It does it for you automatically. Every single time you cross the turnstile, Smartface keeps learning how that face looks and keeps updating the biometric profile. Aging is there, different lighting conditions are there. Sometimes I arrive to the office and I'm wearing a face mask. Sometimes I have sunglasses on. Sometimes I'm wearing a hat. I gain some weight, I lose some weight, I have a different hairstyle. In outdoor environments, we have different lighting conditions. Those are all factors which slightly affect the way we look, slightly affects the way how the camera sees us, and of course affects the performance of face recognition accuracy as well. This is well handled by the watchlist auto-learn, which keeps learning all the different ways we look in different times and different environments. And that's exactly how we can achieve extremely high performance and accuracy of face recognition, even in very challenging environments. The most typical challenging environments these days are, of course, partially covered faces, most typically by face mask. But it can be a hat, it can be a face which we capture from an angle, from the side, from the top, in poor lighting conditions. All these conditions are well handled because the more times, the more frequently we use the system, the more accurate it gets. There is one more trick that we are performing when it comes to seamless face recognition, which is, for example, the access control scenario that we already showed you in the video. This is a trick that we call the intention analysis. The intention analysis means that we keep evaluating and tracking multiple people. Let's imagine this is the turnstile that we saw in the video. So here are a few turnstiles, and this is the camera sitting on the turnstile. This is the face recognition camera. And here's the view angle of the camera. Now we can see these three people. One of the tricks is that we see these three people, and in real time, we keep evaluating them. At this stage of this scenario, we already know the result. The decisions are already made. Person 1 can enter, person 2 can enter, person 3 for some reason cannot enter. It can be because that person is an unknown person or they're not wearing a mask. In that case, of course, we keep updating the decision because he can put the mask on later. This is the trick how we can achieve very smooth experience, because we do not start evaluating those people when they already stopped and they're already waiting at the turnstile. That's too late. It means that they're already blocking others. Queues are created, the throughput is not high, the user experience is not high. We start evaluating a person at the first moment when they show up in front of the camera, somewhere in the scene, and we keep updating the decision and we trigger a corresponding action when they get close enough. We just keep monitoring their movement. Besides monitoring their movement individually, we also keep monitoring their relative position, where they are close to each other, far from each other, moving together or moving individually, which is obviously our solution for tailgating as well. We do not trigger any action while those people are just walking around, talking to each other, leaving for lunch. We only trigger the door when some of those people are moving intentionally towards the turnstile. Obviously, they're walking towards the gate and they're trying to cross it. So this is the intention analysis, which is a very important part of seamless face recognition. In the next video, I'm going to show you another case study. This is not our building. This is not the Innovatrix HQ building. This is a smart office building in Singapore, which we recently delivered, and our platform is used for different purposes. Just a couple of weeks ago, I visited this building. I visited our partner, which has their office in this building. So what I did, and I recorded into this video, I used my own cell phone. I downloaded the mobile app of this smart building, created a visitor profile, which is linked to my partner, which is sitting in this building. And now in the first part of this video, I'm going to take a selfie in this mobile app. And this selfie is going to be attached to my visitor profile. This is an automatic selfie capturing module, which evaluates the quality of the selfie, and it takes the selfie once the quality is good enough. So now the selfie is created, attached to my visitor profile. And in the next part of the video, I'm going to approach the turnstile, which has exactly the same user experience, captures my face, does a few checks. But in this case, there is an additional integration, and there is an additional instruction as well on this second screen, which is telling me to floor 7, go to elevator A. Again, we achieved a completely seamless experience, because when I registered my visitor profile, that was linked to my partner's account, and my partner's office is on floor 7. We achieved two different things here. First, the experience is completely seamless and touchless. I don't have to do a thing. I just keep walking. The elevator is already on the way to pick me up. So this is the user experience portion of the story. And the security portion of the story is destination control. I only can access floor 7. I cannot access any other floors. So this is the security portion of the whole solution. Now I proceed to this lift lobby. I take a look at this third screen, which also shows the schedule of the elevators. Now I can see that elevator A is on the way, and floor number 7 is already pre-selected for me. So when I continue my journey to this elevator and elevator A arrives, I enter this elevator, and when I take a look at this panel with the floor numbers, I can see that floor 7 is already pre-selected. So what I did so far, I downloaded an app, took a selfie, and then I just kept walking. I entered the building, crossed the turnstile seamlessly without stopping, without proving my identity. The elevator was triggered. The elevator came to pick me up. I entered the elevator, and now the elevator took me to floor 7 without me doing a thing, completely seamlessly and completely in a touchless way. Now I'm on floor 7 on the hallway. Now I'm going to enter this office. I'm going to try to open this door. This is not an automatic roll door, so I have to try to open it, but it's locked. I couldn't open this door. But what I can see is that there is a face recognition camera, again, hanging on the wall next to this door. So when I look into this camera, just for half a second, in the next part of the video, when I start it again, you will see a small green blinking light, which means my face was recognized, approved, and the door is unlocked just for a couple of seconds, so I can open the door and I can enter this office. Next time when I leave this office and I try to enter another room again, I keep walking, this camera recognizes my face. While I'm walking, there's a green light blinking, unlocks the door, I open the door so I can enter. Note that in this particular case, we used exactly the same technology, the same tricks for seamless walkthrough experience for access control. But don't forget that this is an individual door for an individual office. This is not the lobby. So now if we change the story a bit, and I'm not a visitor, but I'm an employee of this office, of this company here, and I register myself for the first time when I get hired using my mobile app. Then I walk into the lobby, I walk through the turnstile, I use the touchless elevator, I get to floor 7, and I go to my office in the morning. It's not only the right time for access control, but that's only the right time for time and attendance to punch me in. So this is how we can combine, again, multiple use cases for access control and time and attendance without forcing that genuine user who is playing by the rules to do a thing. we don't have to force him, right? He doesn't have to stop. He doesn't have to prove his identity. He doesn't have to look for keys, place his fingerprint, or to use one device for access control, another device for time and attendance. There is basically no interaction. He just keeps walking, and we do all the job for him. All the feature set, the whole feature set which was used for access control, including tailgating detection, mask detection, intention analysis, is also available here because it uses exactly the same platform, including liveness detection, which is, again, a very important topic here. Smartface supports two different methods of liveness detection. One is what we call the cropped face liveness, or we call it liveness at a distance, because it evaluates the face itself, and it's able to differentiate between the original photo of a real, live, genuine person and some sort of fake, which can be a printout, a printed photo of a different person, or a tablet screen showing a photo of a different person. So this is number one. Number two is evaluating of the body pose. This does not evaluate the face itself. This evaluates the body skeleton, and what we are looking for is this pose when a person is holding their arms in front of their face. In that case, we assume that that person is trying to cover their face with something. It can be a tablet or a photo, or they can wear a mask, of course. And those are the attempts which we can reject automatically. So these two different ways or methods of liveness detection are supported in Smartface. So now what's next? I already registered myself seamlessly using my own cell phone, entered the office, seamlessly walked through the turnstile without stopping, without interacting with the system. The elevator automatically took me to my floor without me doing a thing. I entered the office. I'm also punched in automatically. So what's the first thing I do when I enter the office? After having a coffee, of course. After having a coffee, I go to my desk, fire up my laptop, and I start working. First thing I do, I open my email, I open my CRM, I open the document sharing tool, any platform, any digital platform that we use at the workplace. And of course, I start typing one password for email, another password for CRM, and so on. But don't forget that at this office, we already have a central identity management and face recognition platform, which we already used for the mobile app, for the turnstile, for the elevator, and for the office door, and for time and attendance. So why don't we integrate the same thing into a single sign-on platform, which handles all these corporate tools, including our email or CRM? So if this is my PC screen, all I'm going to do, I'm going to look into the webcam. This webcam connected to the central platform identifies my face, verifies my identity, and now I'm redirected to my customer support portal when I'm logged in automatically without typing a password. So what we achieved here in this smart building is a complete coverage of all the touch points where some sort of identity verification is required using one central trusted source of the identity and one unified identity token, which is our face. Instead of card at the turnstile, we have face and seamless walkthrough. Instead of another card or fingerprint or interactive face recognition device at the office door, we just keep walking and open the door, which unlocks automatically. Instead of pressing number 7 at the elevator knows which floor we want to get to, and also the elevator knows which floor we are not allowed to enter, including our personal devices, which unlock automatically when we look into the camera. Similar solutions are deployed and being actively used in other projects as well. These are a couple of other case studies in Europe, in Hungary, where in this office building we handle more than 6,000 different employees, multiple speed gate lines, 40 different access control cameras for different purposes. And a similar solution is also deployed in the Middle East for a large university campus where we handle more than 30,000 different users, employees, students, which use this seamless face recognition technology for accessing the university campus at all the entrances. Not only for pedestrian lanes, but also for vehicle lanes, where these access control cameras are used to capture the driver's face in a seamless way. The driver doesn't have to leave the car. They just slow down and drive through automatically when the gate opens. In my imagination, the new era of smart workplaces should be something like when we are very good friends with the doorman, right? He knows us. We don't have to stop. We don't have to show him an ID card. When we walk towards him, he opens the door automatically. We just greet each other. We just walk in. He's not asking us questions like who you are, what do you want, and so on. Exactly the same seamless user experience can be achieved by applying modern face recognition technologies with a central, single, trusted source of identity. Thank you very much.
Okay. Okay. Hello. Thank you, Mate, for your wonderful presentation just now. And then I open the floor. If you have any question, you can type your question at the Q&A section, or you can raise hand to ask question directly to Mate. Okay. I think there is no question from the floor. And in the discuss, okay, there is what kind of backup is there in case of errors in identification? From Mark.
Thank you very much, Mark, for the question. So yes, of course, this is a very good question, and we always have to think about fallback solutions for any kind of error. So we can talk about a very common situation with twins, which look exactly the same. So when it comes to twins, for example, and face recognition, of course, the answer is if a human cannot differentiate between those people, of course the machine cannot do it either, right? So yes, of course, we need some sort of backup solution. And here the sky's the limit. Basically, these solutions, these systems, including Smartface, are built for integration. They have open interfaces. They can be incorporated into any kind of larger system, including any other identification method. So it can be a card, it can be fingerprint, it can be a QR code, it can be a PIN code. Basically, there are no limitations here. We can incorporate any second factor authentication method.
Okay, there is a second question from Indy. Can we use single camera to solve multiple tasks?
Of course, very common question. And yes, of course, technically it's possible. Having the intention analysis and all those features that we talked about, we can evaluate and we can determine the position of each person in front of the camera, including which turnstile they're trying to approach, what the distance is from the turnstile, and so on. Of course, the actual scene and the actual setup always can have some sort of limitations. So limited view angle, limited height of the camera, and so on. I would say this is case by case. So technically, yes, it's possible. We always have to see the actual setup of the turnstiles and the actual scene, so we can evaluate whether or not this is feasible.
Okay, thank you for your answer, Mate. Is there any question from the floor? Okay, I think so far. Okay, no question, no further question. Okay, I think that's all for Mate session. Thank you everyone for listening. Then thank you Mate for presenting. Okay, we will take a few minutes until 11:45 for the next session. Okay, thank you Mate.
Thank you very much.
Okay, you can click the go back button.